This problem is an example of a vector addition problem, because there are two forces acting on the spaceship that are not parallel to each other. You notice here that we have a 2,000 Newton force this way. We have a 3,000 Newton force that way, and the mass is 5,000 kilograms. And the question is, what is the value and the direction of the overall acceleration of the spacecraft? Well, we know that just from looking at the picture, the answer should end up being somewhere in this region, because obviously the spacecraft is going both right and up, so we're not surprised to find out the answer is going to be something in that general direction. Alright, in order to do this kind of problem, the easiest thing to do is find the net force first, and then we can just use the net force equals the mass times the acceleration equation. So this is an example of how to add vectors. So we start with the vector on the x, and then we add to it the vector on the y, and then the answer ends up being from the beginning of the first vector to the end of the last vector. So this is known as the resultant. Well, if this is 2,000 and this is 3,000, well then, using Pythagorean theorem, we should get the answer to this. So the resultant is going to be the square root of 2,000 squared plus 3,000 squared, and that will be equal to 3,605 newtons. All right, now that's the magnitude, but what is the direction? Well, that would be this angle right here. Well, according to the triangle, we know the opposite edge, we know the adjacent edge, and so trig tells us that the tangent of that angle is equal to the opposite over the adjacent. Therefore, the angle itself is the inverse tan of that, and kind of realize that's going to be the inverse tan of 1.5. So theta equals 56.3 degrees. Okay, so the net force is a value of 3,605 newtons at an angle of 56.3 degrees. But the question is, what's the acceleration? And so here we obviously use our very well-known formula, net force equals ma. So the net force is 3,605 equals 5,000 A. So A is equal to 3,605 divided by 5,000. So the acceleration equals 0.72 meters per second. Now the direction, according to Newton's second law, the direction of the acceleration actually has to be exactly the same as the direction of the net force.